Lecture 8. So lab, depending on the weather, depends on the weather. What we'll do there, if it's going to be cold, which I think it might be, we'll have some things to do inside. If not, we'll go out and start talking about ventilation. It's a little bit warmer. So stall assignment, time assignment, 23rd and the 7th. National Dairy Challenge. I need to submit registration applications this weekend. So here's the details. We're leaving March 31st, 30th-ish. We have to be there by 6 o'clock Thursday. I'm not sure what we can do with morning flights and the travel time. The competition team would like to fly. So 300 of that 350 is plane fare. If somebody would like to go and that presents a hardship, talk to me. We can sort through that. The event ends at like 6 or 7 on Saturday. Generally, we stay the night and come back the next morning on Sunday.
And you said this is the one that we can do regional again after.
Yes. So anybody interested still with that price tag? And we're going to, Keenan, you thinking of going or not? Okay. If you change your mind, let me know. We need to have you registered by, we could probably with the academy register late. I'm guessing there'll be openings, but the more we can register by the deadline, the better off we are. So there's a lot of things that have happened since COVID. I got to sort things out. There may be some opportunities to do some fundraising to get that cost to you down. We'll see what we can do. I've got a whole lot of binders left over from the regional in the fall. If we could give them out to alumni, they have our logo on them for like $25 a piece. We might be able to raise a few $100s. It'll help defray costs. So you've got this slide handed out to you. We'll get that Dropbox set up. Any questions or concerns?
I'm in this lab.
Okay.
Would there be any way to upload like an example of what you guys come up with for?
We're gonna get all that stuff uploaded. I probably need to meet with you and go through exactly what we did, but we can arrange that.
Okay.
Do you have something in the near future you want to do, or should we just check with it next Monday?
I mean, we can check next Monday if that's good with you.
That's fine.
Okay.
Just remind me and we'll get that made up for you, okay? So, anything else?
And do we have to fill out anything to register?
No, I can handle that. What'll happen is I will put your email address in, and then there'll be things that come automatically to you that you need to fill out. At some point, you're going to need a resume. Do all three of you have some form of resume? That's a requirement now. So you'll be asked to fill out different stuff about your demographics so the sponsors can decide if they want to meet you or not. So, but the process starts with me getting you registered, and then I'll let you know when to start looking for that email. And if you don't see it, whether it ends up in the junk email or anything like that.
I was just double checking about the price.
Okay. If that's a hardship, there are things we can do. So, but that's sort of where we are. That's basically covering the plane ticket. I saw plane tickets as cheap as $230. Figure or $250. Maybe we can get it down that low. Especially if we go to Chicago and take a van north from there. It's like 200 miles. So 3 hours, 4 hours. I'm not sure It'd be the same amount of time if we flew into Chicago and then flew up to Green Bay or the North American Intercollegiate Dairy Challenge. If you look up dairychallenge.org, that'll get you there. You have to look at the events down low. So we did the maternity housing fact sheet worksheet in lab, a brief review of that. When we're designing maternity spaces, we want to make sure that we have everything that the mom needs, the birth needs, and then the initial newborn things that are there. If we can have everything close, so this is the fact sheet in your facilities handout. We want to make things as easy for us as easy for the cow. And as soon as she has that calf, we want to make sure that there's a opportunity for her to eat and drink as we go forward. We want that calf to arrive in a clean environment, free of little particles and contaminants that can be sucked into their lungs. We're trying to get that straw in there so they're not going to get that down their throat as easy as dirt particles or sawdust particles. The first thing that goes down their throat is what gets to the gut first. Once something's in the gut, it closes. So we want that first thing to be colostrum. So looking at what we may or may not be able to do, we've got that 140 square feet per cow. So that's a 12 by 12 or 10 by 14. We want to think about, we've got that animal lying down. We want to be able to work behind that animal. If we have to get a jack in there, and you're looking at probably 14 feet to get that done. So we talked about in lab, straw over another layer that provides drainage, easily clean feeding space, convenient feeding space. This was a nice little arrangement where they had these tubs on wheels up at Minor Institute. They put however many they needed to get filled with the close-up diet or the fresh cow diet outside. The feeder would come by, put feed in them, and then they could wheel those back inside the barn, and then they locked into place at the headspace, headlock, for that animal to have feed. So fairly easy to tip, tilt, and empty. It didn't involve a lot of double handling there. The feeder could drop stuff directly, and then you just had to wheel it into place, lock it into place, and the animals had access. So making sure that they have that feed and water, making sure that you have the resources necessary for all the range of things that can happen. So water, head gates for restraining if you need to. Everybody seen the gates within the gates that can swing into place to lock this animal? So you either have a double gate hung there to kind of squeeze that animal and get that animal into a headlock by yourself. There are some designs where you've got a gate within a gate. You've got a bigger gate, and then you've got a smaller gate that you can use as a squeeze to get that animal where you need to go that comes out of the gate. Has anybody seen those? So one person has seen those?
What you're talking about.
So see if I can draw it and make it a little bit clearer. So you've got headlock, and then there's a gate or section here that may or may not be movable depending on the way things are. There's sometimes you've got a hinge.
Oh, not like that, but I've seen the double gate.
Yep, so a gate within a gate. So you can unhook it here, swing it around, and pull that animal into a headlock. So In theory, those animals are fairly tame, not terribly strong, I guess. So that smaller gate should help get things done. So all the things that you might need, that animal needs assisted. Do we have that stuff close, or is that somewhere far away? Do we have electricity? Do we have lights so you can see what you're doing? Do we have access to clean those pens easily, especially between calvings? We'd like to get everything in there taken care of. So this is a case where we've got easy access. We can get those gates open. We can push right through. There's are some places where you'll have, if they've got stalls coming out, you instead of stalls continuing, they have box stalls in the middle, and then either side's an alley. You can push stuff across in either direction to clean out that between calvings. So we talked about in lab the things that you're looking for. So the green things are the things we're looking for. Those answers, if we answer those questions, we're doing things the way we might want to. If we answer red, there's an opportunity for improvement. So we're talking about the management of the calving pen, the dimensions of it. What do we have there that's going to make that birth successful and not cause problems for both the cow and the calf? Do we have access to feed and water? Is there a good environment there? Ventilation tends to be overlooked in calving areas, and we probably need to do more there than we do in other places. And then we ask, can the cows be restrained? We hope by one person. Can the animal be lifted if we need to? Do we have a beam in there that we can hook to? Or can we get a skid loader in there to help lift things up? And if worst case scenario happens, do we have an opportunity to get those animals out in a convenient and easy manner? So any questions about that review of what we talked about in lab? So floors. If we're thinking about floors for our animals, what should be present? What do we need to happen with floor? Grooving is helpful, so that provides what? What's the purpose of grooving? Traction. It's all about traction. We need to have, the cow's foot isn't designed for smooth concrete for a number of reasons, so we need some sort of traction that mimics what they'd find out on a good pasture. So the floor should, again, we're looking for that perfect, well-drained pasture. See how close we can get to that. So the floors need to be clean. If those hooves are continually exposed to wet, exposed to bacteria, we can have a breakdown. Those hooves are just protein. If we got a continual exposure to that manure slurry, we can run into problems. They should be free of anything that can damage the hoof. So we're looking at sharp points, things that are sticking up, rocks, pebbles that are big enough that when a cow steps on it, they are going to not allow her to get her whole foot to the floor. So when we're doing sand bedding, we got to make sure those rocks aren't there. They step on those rocks, they're going to probably separate their hoof from the sole, the wall from the sole on the white line. Anything that's nails and things like that, I was taught at a very young age to be able to spot those things and pick them up. I still, for whatever reason, can see nails in a lot of different directions real quick. So making sure that there's no problems there. So loose or damaged concrete, can damage a hoof, stones, sharp points or edges, anything that's going to cause damage to those hooves, we need to make sure that they are not there.
Did you ever figure out where all of those stones came from on that one cow we dissected?
We're assuming it was when we were packing the silo, the big loaders came in and dug too much and they got macadam, or we probably had some open spots there, but you can see in the silo over the summer there was a layer of rocks. So every morning after we shaved it off, we went through and pulled out the rocks we could get to. So the next day when we shaved, we were back to that flush area. So you're taking like 6 inches out. Then you came through and shaved out, but we assume it was during the filling of the silo that they got introduced. So that's the only thing we can think of. And that cow, for whatever reason, decided she wanted to. She wanted to consume them preferentially. Most animals will spit them out. We like our floors to be well drained. So for a couple different reasons, we're looking at ice in the winter. So anytime we're dealing with temperatures in the single digits or lower, we have icing problems up in our heifer barns. So they're trying a couple different things this year. They're not cleaning as often because it's not wet, so you probably don't have to. They're throwing sawdust down. We're thinking about maybe sand to help with those lower heifer barns, the lower one and the upper one. We have to also think about the summer, the drainage. If water sits for any length of time, you're going to have algae or slime mold or something that can make that surface slick. And we like to avoid that in the summertime as well. So it doesn't take too long for those single-celled organisms to get going, to get everything done in one way or another. So we'd expect our floor to provide traction, to help those animals walk with confidence, to help make sure they don't slip and fall. I know I still have that sound in my brain. One of my cows slipped at my dad's place, and you could just hear that femur snap. Just a thud, real low thud, and it's like, she ain't getting up. So didn't get the non-skid on there as quickly as we should have. Or just a bad day, whatever it was, but I don't remember the circumstances other than she went down, and I still remember that sound. We want traction, but we don't want to be abrasive. That protein hoof is not meant to be beat on repeatedly. So we're looking for issues, especially with new concrete, where we've gone through and made sure we get all the sharp points out. Is that in here? Has anybody heard about what can happen with new concrete, or what happens with new concrete once it's formed? So new concrete, after you've floated it, it's going to go through and have little micro points on it. So very short, very pointy little things that will form as that concrete cures. If you don't go through and cut those off, so people go through with a skid loader, run the bucket over to try to break those points off. There's a number of different things you can run back and forth that you're trying to take those little tiny points off. If you don't take those off, it's like they're walking on cheese graters, and it gets rid of the entire sole. So we need to make sure that on fresh concrete, we go through and beat it up a little bit to get rid of all those micro points. And then making sure that we have a floor that's not going to act like a cheese grater and take those soles off. One of the concerns up at the dairy right now is that there is, we've got thin soles according to our hoof trimmer, and we're not really sure how that happens up there. We've got rubber pretty much everywhere. So the question is, why is it happening? We think the only theory we've been able to come up with, and we're open to suggestions, that the heifers learn to kind of scuffle when they're young down in those lower barns, and maybe that way of walking continues up there, and they're using the grit that we put down to help things not be so slippery. Maybe that's in combination with the way they walk is causing problems. There we go. Take big confident steps, I guess, right? But that's a pretty weak explanation. So we're thinking more about that as we move forward. So you've got a flooring fact sheet and a flooring worksheet in your packet. So if the concrete gets too slick, there are a number of things that you can try. You can cut new grooves in the floor. And when we're cutting grooves, we want them to be in cross section, we want them to be sharp points, which can be a challenge. So if you're looking at the floor, cutting it across the floor, we want our grooves to be shaped like that, not like.
Oh, when you cut it down for it to be parallel.
So you're looking down the floor. So we don't want them rounded. We don't want them sloped. We want to have that sharp point, right angle that's going to catch the cow's foot as she pushes in. Usually we run the grooves parallel to the way they're going. That groove cut right. Most people go with scrabbling. I think it's a little bit cheaper and more cost effective to get things done. That roughens up, you're beating up the surface, taking off that slick top layer and getting down to some of the aggregate that's gonna hopefully provide some traction. The challenge with that is cleaning. Things have places to get caught going through. There's another suggestion that if you can free up a section of floor for a certain period of time to allow this to happen, you may be able to put a texture on the floor that might stick. So you've got to clean the floor, prep the floor, put down the stuff, and then allow it to cure. And sometimes that's a challenge. That do we have that much time to make that floor inaccessible? But it's a suggestion that we take paint in some way, shape, or form. We put down a thick coat of paint, and then we throw in some sort of sawdust or organic matter, coarse cornmeal that provides a texture in that paint. And then as that organic matter falls away, the sawdust, the cornmeal, we are left with a surface that's got a lot of pockets in it that might provide traction.
But the cornmeal, does it have the same effect as the new?
The cornmeal should not be sharper or harder than the hooves.
Okay.
Whereas cement's going to be way harder than the hooves. The corn should break down under the weight of a cow. So it will go away. You may have to do this frequently. You could also probably try the same thing with epoxy. Anybody here surf? One of the things to get traction on a board, they use wax to do that, but they also sometimes take epoxy and put that layer on the top and they'll put sugar in it. The sugar gives that a texture that your feet can grab to. Now that might be a little bit sharp, or the epoxy. So I don't know if that's going to act as a cheese grater or not, but with the surfers, they take the surfboard in the water, all the sugar dissolves and leaves little pockets and texture to that epoxy that will allow you to grip with your feet. So the problem with this is that you may have to do it more often, but it is an option, and you have to decide, cows slipping, what is that worth to you versus the cost and time and inconvenience of doing that. If we're looking at grooving, we want to have the grooves run parallel to the way the animal is moving. So the idea is that they're slipping in either direction as they're moving. Those grooves will catch. We also have the diamond patterns, usually where you've got a parallel set and then an offset coming over. They're a lot easier to put in that diamond pattern when you first put the concrete in than to go in retrospect and then put it in after the fact. There was this instance when they're up at Minor Institute, they would put grooves in the winter time. Has anybody ever seen a bubble curtain? These curtains that fill up with air, and they're basically like a mattress, and each tube fills up and they stack up in kind of a reinforced area. Somebody had those curtains up when they were doing that, and you had thousands and thousands of little pinholes from where the rocks got thrown through that bubble curtain. So that was not a smart day for whoever forgot to lower those bubble curtains. You do the same, you get holes in a curtain as well. So if you're putting that groove into a floor, you're looking at something about a 1/4 inch by a 1/4 inch. That box we drew over here. So 1/4 inch down, 1/4 inch over, 1/4 inch up is what's recommended. Most of the grooves I've seen are a little bit bigger than that. We talked about that groove, that cross section to be a square. And we're looking at spacing where the animal's foot is going to catch 2 grooves. So if it's 5 inches across and your grooves are 4 inches apart, she should be on 2 grooves most of the time, or will be shortly as her foot shifts in a direction. So 2.5 to 4 inch spacing on those grooves. Diamond pattern, we can go a little bit more, a little bit bigger, because she's going to hit, if there's 5 inch on the sides of the diamond that are made, she can't go real far without hitting those grooves. It'd be very difficult not to step on those grooves. You have to place that foot more or less perfectly. So our sheet, again, we're looking for answers that are in green, our yeses, versus our no's. Basically a checklist of all the things we've gone over. Are the floors clean? Are they readily cleanable? Can we get in and clean things the way they're supposed to be? Free of hazards that could damage hoof, free of standing water. Do cows move across the floor with confidence? Do they walk without slipping? Do the floors wear or injure the hooves of the animal? So what is the interaction between the animal and the floor? And is it a positive experience as opposed to a negative experience? And then if there are grooves in the floor, how do you evaluate those? Going back to our specs, are we looking for something that's going to allow more or less of a hoof or a foot to be in constant contact with at least one groove in the floor? Any questions about floors? Pretty straightforward. So. I know one of our challenges is that return alley, keeping that from being slippery, ice in the winter, slime in the summer. That's a challenge. So just the last pages, ventilation, there's in there, but we're probably going to skip most of what's in there. The last pages we're going to focus on are your cow comfort pages. You have, if you're doing all of the things right related to stalls, related to cleaning, managing your cows, we should have comfortable cows. We've mentioned these before. How do you measure whether animals are comfortable? There are one approach, and again, these equations are in that section. Cow comfort, it should be after the water section, I believe.
After water is
Ventilation.
and then ventilation.
Okay, so that's right before water. You're looking for a pie chart.
That's feed bump.
For the feed bump.
It's just this one.
Okay, there's that page, and then the back side's got a pie chart. So,
Oh, yeah, there it is.
so it's right before the feed section.
Yeah.
Okay, so on the fact sheet, we got a reminder of those formulas. The text tells you how to do those. The proportion of animals lying in the stalls if you're dealing with a tie stall. So in Japan at the time, there was still a lot of tie stall farms. So you'd expect when you're not doing something with the animals, the post-feeding, post-milking, that 85% of them should be lying down. So how many stalls have an animal in them? What percentage of the stalls that are filled have a cow lying? So 8 or 9 out of 10 animals should be lying down. So the problem with this is you only have stalls. That's okay in a tie stall housing. The free stall housing we talked about last fall, shifting over to account for, okay, all the animals that are not eating, drinking, grooming, should be lying down. And do they have enough stalls to get that done? So animals that are not doing those other activities, they should be in a stall and lying down. So you've got all the animals that are in stalls lying down, and then you've got all the other animals that should be lying down, and are they doing that or not? So 3/4, 3 out of 4 of the animals eligible to be lying should have access to a stall and be in that stall lying down. And again, you're doing this a couple hours after milking, somewhere in the night is the best time to look at this stuff. So especially when you don't have a large classroom of students showing up and disrupting things. So when things are quiet, get in the habit of thinking, are 3 out of 4 of the animals that are eligible to be lying down. This allows for overstocking at the stalls. So you may have some animals that have to wait their turn, but that 75% down from 85 allows for that to happen. So given how cows are spending their days, we talked about averaging those sort of out. These are the numbers that Rick Grant comes up with. What is she doing? So we've simplified this to the 5.3 plus a half, 6 hours eating and drinking, rounding this to 12 hours lying, and then 3 hours being a cow leaves you 3 hours, or you've got 3 hours being a cow, you've got remaining time to do what you need to do. So think about the time budget. How long is the average cow away from resources when you take her to the pen? How many hours a day are we in headlocks, not allowing that cow to do what she wants? So a table showing those same numbers, close to those same numbers. So if a cow needs 20.3 22.3 hours a day to do what she needs to do. We can only interrupt her anywhere from 3.7 to 1.7, according to the numbers that we have here. We simplify that. Usually you can take about 3 hours a day. Normally, we're not going to sit around and figure out how long are they eating, how long are they drinking. We make the assumption that they're resting a certain amount, although there are companies that will come in and do that audit for you. How many hours a day are your animals lying down? We don't measure all that stuff, so rule of thumb is we've got 8 hours, 3 hours to do what we need to do. So if you're milking 3 times a day, those animals have to get to the parlor and back in 3 hours, 3 times a day. Some of the larger groups of animals, that can be a real challenge, especially for the tail end animals, the animals that are not moving as well. Getting in and getting out can be a real challenge in that 3 hours. So thinking about ventilation, that's the next topic we're going to get to. How does that all work? What are the principles? And it really comes down to how does the air move? So when we ask that question, an analogous question or a similar question might be, what is wind for our purposes? So does everybody know how wind forms? How or why does air move? So everything moves from a high pressure system to a low pressure system. So given the way the Earth spins, we have the sun hitting different spots of the planet at different times. That sun hitting the planet is going to increase the pressure and create high spots or spots of high pressure air. Given that high pressure, that heated air tends to rise. And as that air is displaced, more air comes in and everything moves from a high to a low. So high pressure areas on the planet move to low pressure areas. Low pressures are usually associated with storms. Has anybody done weather and weather forecasting in your previous? We did it in 7th grade in the school system I was in. I got to predict, we had to take turns predicting the weather for the next day. I got to predict the next snow day. That was fun. Said, tonight's forecast over the announcements is snow. And we had a snow day the next day, so that was fun. So everything moves from a high to a low. If it can, it will follow the shortest route to get that done. But if there are windbreaks or things interfering in the way, the air will go over it, the air will go around it, might be slowed down, but it still will flow, just not as fast or as efficiently if we've got breaks in the middle. So we're thinking about ventilation. We want to ventilate a barn. There are a number of different things we want to move. We want to move the air, get fresh outside air in, stale, wet, stinky air out. In the summer, we want to move the heat that's created by the animals out of the barns and keep that inside of the barn more pleasant or cooler than what's surrounding the animals. So our lactating cows throw off a lot of heat. That rumen constantly generating heat. We need to move that heat out. The animals, we're dealing with the moisture that they breathe out, the moisture that evaporates from their feed, from their manure. All that stuff needs to be moved out. And then all the compounds that are associated with smells. We got ammonia, we've got rotting things, all the things that chemical compounds that produce a smell that might get in those lungs and somehow damage or cause problems. So with ventilation, we can do it mechanically. Some sort of system where we use fans, so we have an electrical input, we have hardware for that process. It costs money. On the plus side, it's consistent. We can have natural ventilation where we design things in such a way that we create low pressures inside the building, so air from outside moves inside. But depending on the day, we may have those still hot summer days where we really can't generate that difference, and it becomes a real challenge to make that happen. So with both mechanical and natural ventilation, we want to have a system in place that is planned. We want to know where the air is coming in. We want to know where the air is leaving.
Are those air tubes, are those natural?
The air tube is a mechanical. It's got a fan at the end. You're directing with windbreaks or whatever. That tube is a windbreak that's going to move those holes into different locations. We need to have a driving force. We need to have a pressure differential. We need a high area of high pressure, and we need an area of low pressure. So we can generate that with mechanical, with fans, or we can generate that in the way we set up a natural ventilation system, that air is going to come from outside the barn, inside the barn, and then leave again. And when we're doing ventilation, we want to make sure that we turn over all of the air in the system. So that means getting down at calf level. That means getting down to stall level. We want to make sure that the barn doesn't have spots where the system short circuits and this area doesn't get covered. This area does. We want to make sure that there are no dead spots. We want to make sure that there are no areas that are getting a whole lot more ventilation than others. So drafts versus dead spots. We'd like a uniform flow of air, slow and steady throughout the barn, and should exit as we plan it to, one way or the other. Usually opposite of where it comes in. It comes in, traverses the barn, and then goes out. And there are a lot of different systems that we'll talk about that get that done. That makes sense so far? Okay, I got a quiz for you. We'll end with that. So as soon as you're done, you're free to go. So when designing heating or water spaces, what things do you have to remember? What principles do you need to have in some way, shape, or form? Give me 3 examples for each of those.